So let's summarize a whole bunch of families of functions, of exponential functions, where the base is not equal to e. So remember, we said that the derivative of e to the x is just e to the x. So what if I have any constant, a raised to the x? What is the derivative? So we've seen how to do this, so let's summarize this. So remember, we said that if we have y is equal to a to the x, and I'm trying to find what is the derivative of this, I can do logarithmic differentiation. So I take the natural log of both sides, natural log of a to the x, then I take the derivative of both sides with respect to x, ddx of natural log of y is equal to ddx of natural log of a to the x. This derivative, what I get is I get 1 over y times the derivative of the inside, dy dx. The derivative of x in this case is here. What I have is I have the derivative of natural log. Well, I guess two different ways. One, you could take down the x if you wanted to, right? That rule always works. So let's do it that way. So I have ddx of x times natural log of a. The derivative of this right-hand side now is x times a constant. The derivative of 3x is 3. The derivative of 5x is 5. The derivative of x times natural log of a is just natural log of a. So this is going to be 1 over y times dy dx is equal to is equal to natural log of a. Multiply both sides by y, I have dy dx is equal to y times natural log of a, but y was a to the x. So I have dy dx is equal to a to the x times natural log of a. So that is the general derivative of a base raised to the x power. Notice when the base is equal to e, this simplifies, right? I have e to the x times natural log of e. Natural log of e is 1. So this holds even for e. So that's it. Now, what that means then is if I want to try to reverse this, I want to try to find the antiderivative of this, trying to figure out what function has a derivative equal to a to the x. In other words, what would I take the derivative of to get a to the x? Well, if I take the derivative of a to the x, I get a to the x times natural log of a. So that natural log of a is a little bugger that we want to get rid of, but it's just a constant. So what this means is that if I was to divide this over, so what this is equal to is a to the x natural log of a, but if I take ddx of 1 over natural log of a times a to the x, now the derivative of this, the natural log of a's are going to cancel, and it's a to the x. So the integral of a to the x dx is going to be 1 over natural log of a times a to the x plus c. So that is the general antiderivative. Now, again, we're not going to deal that much with this because e to the x is our go-to exponential function. But just in case you see something like the integral of 2 to the x dx, if you know this, then you can immediately find this pretty quickly. This is going to be 1 over natural log of 2 times 2 to the x plus c. So that is the antiderivative of any constant raised to the x power. Just use this rule.